just going to do a quick recap of everything, and then we'll try and move on. Okay, while we're doing copper sulfate was very important. Remember, it's a blue solution. Copper sulfate specifically, you should know what the color is. This one over here is a blue solution, and you got copper ions, you got sulfate ions, you got H plus one, and you have OH minus one. The positive ions, they get attracted to the cathode. The negative ions, they get attracted to anode. Uh, who gains electrons? Copper or H? You look at the reactivity series and you look for the least reactive. Okay, so it was copper ions that would gain electrons and they would turn into copper, and you'll see a pink shiny metallic deposit on the cathode. And on the other side, who loses electrons? OH or SO4 minus 2. So remember, it's always OH ions unless the halides are concentrated. So it's always OH ion. For this, you need to remember the equation of OH ions losing electrons. So it's going to form water and oxygen, and it will lose electrons, 4 of them. And because oxygen gas is being produced, what you'll notice is bubbles of O2 gas. So on one side, the OH ions are gone. On the other side, the copper ions are gone. So you're left with H and SO4. So basically, your copper sulfate turns into H2SO4. So your solution becomes acidic. So it turns from copper sulfate, blue copper sulfate, to acidic colorless sulfuric acid. तो इसको वो भी लिखते हैं, the blue color fades, right? So is this all clear? We did a lot of aqueous solution electrolysis. Is this clear?
जी सर.
So now the next thing that we're going to do is we will talk about electroplating. Okay, we're going to talk about we're going to talk about electroplating, and we will also talk about purification of copper. So starting with the first one, electroplating. So what is electroplating? What you do in electroplating is that you coat uh, a metal object. Normally, it's a metal object is coated with a less reactive metal. It is coated with a less reactive metal, which looks good. For example, you coat something with gold, and it also protects it. It prevents rusting because it's less reactive. So, for example, you've got a steel watch, and that watch gets coated with gold. Okay, so it gets a layer of gold on top of it. So not only does it look good, but it's going to protect the steel from rusting because gold is very unreactive. So there's going to be a thin coating of gold. Could be silver as well. But the trouble with this is that it's not very durable. It's not a very good way of actually preventing rusting, because if the coating breaks, which it breaks very easily, then the steel would rust, and it wouldn't look very nice as well. So anyway, but it as long as the steel coating, as long as the gold plating is there, and you don't get a lot of scratches, and the layer doesn't break very easily, it's still going to be very durable. It's going to be much durable. Compared to just steel. So less reactive metal or less reactive metal. I'm going to give names of metals that are normally used. So you've got gold, you've got silver, you've got chromium as well. and you have copper as well. You get a lot of spoons, etc. Cutlery, etc. Surgical instruments. They are copper plated as well because copper is also very reactive. So, how is electroplating done? Now, there are
सर
some rules.
गोल्ड
हाँ जी,
सिल्वर।
gold, silver, chromium, copper, ठीक है.
सर एक सेकंड।
ऐसे rules कर लेते हैं rules for. ऐसे now remember this very. I mean, listen to this very carefully. Yeah, a lot of people actually make mistakes when they're talking about electroplating. P6 में ना you get big questions on this. So rules for electroplating. Number one, you just have to follow these rules. The object that needs to be electroplated, I mean, which is to be electroplated, is is placed at the anode or is the anode. Second one, the electroplating metal. If you want to electroplate it with gold or silver or copper, the electroplating metal is your anode. And number three, that your electrolyte or the solution or the molten electrolyte, so it can either be molten or it can be aqueous.
सर ऑब्जेक्ट कैथोड पे नहीं होता।
कैथोड पे ना, मैंने वैसे
हाँ ये
बोला
रिटन
वही है,
एनोड।
बोला मैंने वही था, यहाँ पे चेंज कर लो. अच्छा, object is at cathode, electroplating metal is anode, and your electrolyte, molten or aqueous, it should contain uh, the metal ions. You get the one that you're trying to electroplate. So, for example, I want to uh, I want to electroplate a spoon with copper. So how am I going to do that? P6 where they're going to ask you to draw diagrams, and but it could be a 6 mark question where they ask you every small detail about how you're going to go about this. The first thing is whether the anode and cathode are drawn. Chalo. Uh, Now the first thing is I would have to draw a spoon. So the spoon is कितना बनेगी? नहीं बनी ठीक से. तो इसको सही करते हैं. Sorry. Yeah, that kind of looks like a spoon. We're going to use that, and I'm going to attach it to the cathode. Okay, so the rule number one, the negative cathode. The object has to be at the cathode. So my spoon is at the cathode. And the spoon is made out of a metal, so it is capable of conducting electricity. It is capable, metals are very good conductors of electricity. Okay, now rule number one, object must be, if you can see on the screen, object must be at the cathode. And the electroplating metal has to be at the anode. So if I want to electroplate it with copper, the anode must be made out of copper. So I'm going to put a piece of copper over here. Okay, so there's a big chunk of copper that's over here. And then I have my electrolyte. Now, the electrolyte could be molten or it could also be aqueous. In this case, it won't really matter whether it's aqueous or molten. I'm going to go with aqueous. So the electrolyte must contain copper ions. Okay, I mean, the third rule for that was that the electrolyte, molten or aqueous, it should contain the metal ions. So if I'm doing it with copper, it has to be copper ions. So you're going to think of a compound that has copper in it, and that's easy. I mean, you could think of copper nitrate or copper sulfate. So we're going to go with copper sulfate because we just did an electrolysis of copper sulfate early on. So we're going to go with copper sulfate aqueous. And that's my diagram. That's the complete diagram. This is my anode. I'm going to label it. The anode is my positive side. The battery is pulling electrons from the anode and it's giving electrons to the cathode. So it's sending electrons over here. It's pulling electrons. Now we're going to try and do the electrolysis of this. Copper sulfate means that there is copper plus 2 ions which are going to be attracted to cathode. There's going to be SO4 minus 2 ions that which will be attracted to the anode. And since it's aqueous, there would be H plus 1 and there would be OH minus 1 ions. Starting with the cathode, what happens at the cathode? So who gains electrons? Whether it's going to be the electrons are coming in, and we need to figure out are they going to go to copper or are these electrons that are coming from the battery are they going to go to H plus 1? So who gains electrons?
Copper.
तो कोई मुझे ठीक है तो reactivity C is the one that's at the bottom of the reactivity series. We're just going to go back and have a look. किधर गई हमारी reactivity series here? So we'll just have a look. Copper and H. The competition is between copper and H. ठीक है, so reactivity series में it's copper that's lower in the reactivity series. So which is why it's going to be copper. ठीक है, so वापस जाओ कहाँ गए? ये. So it's got to be copper. Copper is lower in the reactivity series, so copper would come to the cathode and it will be plus 2 and it will gain 2 electrons over there. And when it does that, it's going to form copper metal. So what you're going to see over here is, I mean, the H plus 1 is there. It's not going to gain electrons. Copper ions are going to gain electrons. And you will start seeing a thin, shiny, pink, metallic deposit forming on the cathode on top of the spoon. The spoon would start turning orange or pink. So there's going to be pink, metallic, deposit. Shiny bhi add kar lo. Because metals are very shiny. That is how electroplating is happening. The object is at cathode. But then the next question is, ye clear sano ko Shanze Nabira? Zainab, is this clear? Taha, is this clear?
जी सर.
So on the other side, now the question is who loses electrons? So the battery is pulling electrons. So what will happen at anode? So now this is something that's important because the anode electrons could be lost by OH ions. Electrons could be lost by SO4 minus 2, right? So it could be SO4 minus 2, it could be OH. But the rule here is it's always OH ions, except when halides are concentrated, Cl, Br, or I. You don't have Cl, Br, or I in this case. So it's got to be OH. But remember, the anode is not made out of an inert material. The anode is made of copper metal, which is not inert. And we know that since anode is made out of copper metal and the battery is pulling electrons, and it's a metal, right? What do metals like to do? They actually like to lose electrons. So you've got competition over here. There's OH ions, there's SO4 minus 2, and there is copper as well. So someone has to lose electrons to the battery and give the electrons to the battery because battery is pulling electrons. पर यहाँ पे क्या होता है कि it's the copper metal itself that loses electrons because metals they like to lose electrons. So the ions they are not able to lose electrons. So unlike in the previous case, it was always OH ions. But now in electroplating, it's always going to be the copper metal at the anode that will lose electrons. So anode is made of Cu metal, and always the metal at the anode loses electrons. पहले था कि all the anodes were made out of unreactive metals, inert. They were either made out of platinum or they were made out of graphite. This time it's made out of copper. So always the metal at the anode loses electrons. So the metal at the anode was copper. It's going to lose electrons and it will form ions. And the battery is going to lose and take away these electrons that it's producing. Okay, so over here it's the copper metal that will lose electrons. To be clear, there's one difference. You have a metal at the anode, the metal itself starts losing electrons. Well, it's no longer going to be between the ions. If the anode is made out of a metal, it's going to be the metal that loses electrons. ठीक है? ये clear है? Chances, Zarar, is this clear? बाकियों को clear है?
Yes, sir.
So you got two reactions now. On one side, it's copper ions. So copper ions are going to be produced at this side. The anode will start to dissolve. And copper ions are going to be produced because the copper anode will start dissolving. It will start losing electrons. And you're going to see a lot of copper ions forming in this one. So that is one thing that's going to happen. I said now. So remember this. This is extremely important. I said, what is the observation at the anode? The anode dissolves. So if somebody is going to ask for an observation, you're going to write that the anode dissolves. It turns into ions, and the ions go into the solution. And what happens to your solution? So changes in electrolyte. So are there any changes in the electrolyte that are going to happen? Okay, this was my electrolyte. So changes in electrolyte is that on one side copper ions are getting used up, they're being consumed, and they're depositing on the spoon. So the copper ions are being used up. On the other side, copper ions are getting produced back again. So that means the net amount of copper ions will kind of remain exactly the same. So one side removes the copper ions, they gain electrons and they form copper. While the other side, the copper metal loses electrons and it turns into copper ions and it continues to. So the net amount of copper ions would remain exactly the same and there would be no change in solution. There's going to be no change in electrolyte. There would be zero observations. It remains blue. It remains copper sulfate. Nothing is getting used up. Okay, so I'm going to recap everything. Okay, the rules for electroplating were the rules for electroplating were that you had the object at the cathode, you had the electroplating metal at the other side, the anode. And the solution, if you want to electroplate it with copper, it has to have copper ions in the solution. So it has to be a copper compound like copper sulfate or copper nitrate or any other copper compound as long as it's got free moving ions, either molten or aqueous. We went with copper sulfate aqueous. So you had copper ions in H plus one, the battery gave electrons, and who gained electrons? It eventually, copper ions gained electrons because they were lower in the reactivity series, and copper got deposited, and you saw pink, shiny, metallic deposit on top of the spoon. On the other side, the battery is removing electrons, and you have three candidates. You've got OH ions, you've got SO4 minus 2 that can lose electrons, but instead of those two in the solution, it was the copper metal electrode because metals like to lose electrons, so it was the copper metal electrode that lost electrons. And the copper metal electrode started losing electrons, started forming ions. So on one side, ions were getting formed, copper ions. On the other side, copper ions were getting used up. They were being turned back into copper. So as a result, there was no net effect or change in solution. The solution kind of remained exactly the same. Uh, so there was no change in the electrolyte. It remained exactly blue. The anode dissolved, and at the cathode, the copper got deposited. Okay, is this clear? ये सारा clear है? Dilar, Zainab, Rania, Nabila, is this clear?
जी sir.
Yes, sir.
ठीक है. अच्छा, now, अच्छा, we'll do one more, which is let's electroplate your object. क्या object? Electroplate watch with silver. ठीक है, so we're gonna repeat everything. You have your anode and you have your cathode. I want the object to be at the. So let's think of this as the watch. A watch बनेगी किस तरह, एक second. So anyways, this is, so let's assume this is my watch. तो ठीक है, पता नहीं क्या है ये. अच्छा, let's assume that's the watch. And the watch has to be at the cathode, the negative one. And remember, we're electroplating it with silver. So the anode has to be made out of silver, right? So what you can do is you can attach a piece of silver to it. So let's say this is silver, a piece of silver. I'm going to place everything in an electrolyte. It has to be, it could either be molten or it could be aqueous as well. But since we're electroplating it with silver, it has to be something that has silver in it. Maybe silver ions or something. So I'm going to go with silver nitrate, aqueous. Silver is +1. Remember that Ag is +1, NO3 is -1. And if you remember the solubility table, anything that's got NO3 in it, that is soluble. ठीक है, NO3 वाली सारी चीजें जो है ना, वो सारी की सारी soluble है. So anything that has NO3 -1 in it is going to be soluble. So it's always easy to go with nitrates because they're all soluble. So now your solution is going to have the negative cathode and the positive anode. The Ag+1 ions will go to get attracted to the negative cathode, and the NO3 -1 is going to get attracted to the positive anode. and in the solution it's aqueous, so there's going to be two more ions. One is H+1 and the other one is OH-1. So the battery is going to send some electrons, and who's going to gain those electrons? Uh, so the competition at the cathode is between Ag plus, or is it going to be H+1? Who gains electrons? So according to the reactivity series, Ag is the one that's lower in the reactivity series, so it's going to be Ag plus one that really likes to gain electrons, and it will get reduced. The gain of electrons is reduction, and it becomes silver. On the other side, who's going to lose electrons? I told you that you've got two candidates, OH-1 or NO3-1, but if the anode is made out of a metal and it's not inert, then it's always the metal that loses electrons. So silver is the one. So what will happen at anode is the anode के ऊपर ना, the positive anode, uh, the silver metal anode is the one that loses electrons. Metals, they like to lose electrons. So your silver metal, which is present at the anode, the battery is going to pull electrons out of it. It will become silver ions, aqueous, and it will lose electrons to the battery. Okay, so the difference over here is you don't have to worry about these ions. Battery is pulling electrons, so it's going to pull electrons out of the anode itself. The anode is no longer inert, and it's made out of a metal, and metals like to lose electrons, and they're going to lose electrons. So what is happening on one side is there's more Ag+1 ions getting formed, and on the other side, Ag+1 is getting consumed or turning back into Ag. So again, the net result is there would be no change in the solution. One side produces, so this one produces Ag plus, it dissolves the anode, or the anode gets dissolved, while on the other side, Ag+1 is reduced, it gets used up. And Ag gets deposited on the watch. So hence there wouldn't be any change in solution. So hence there's not going to be any change in solution. And on top of the watch, you'll start seeing a silverish metal deposit that will start depositing on top of the watch. ठीक है, ये clear है सालों को? Is this clear? Zareb, uh, Hania, Taha, Nabila, is this clear?
जी सर.
Yes, sir.
Yes,
Okay,
sir.
so ठीक है. So bus back to this. You got to remember the rules for electroplating. ठीक है. अच्छा, the screen is lagging because I think there's a country-wide internet issue. So hopefully it will stop lagging in a couple of days. Achha, but anyways, rules for electroplating. Make sure you remember this. Now, the same rules are also applied to, and this is also something that's very often in B6. That is about purification of copper. Okay, this is something, so the same concept, the same exact concept. So the same exact concept is applied to purification of copper. Now, purification of copper is that the copper ore, the copper ore is the raw form of copper. It's the mineral raw form of copper. it's basically a rock. Like if I show you what a copper ore looks like, that's another good thing about copper is that copper is kind of unreactive. The copper metal itself, it's very low in the reactivity series. So Cu is less reactive. So what happens is that when you go into the nature and you try to find out copper, so copper is sometimes found in the native state, in the original state. Like if you've ever seen gold panning, gold nuggets are obtained in the original state. I mean, you don't have to do any chemical reaction. You just have to sort of purify it or search for it. And that same thing applies to copper as well, because sometimes you see rocks which are made out of pure copper. So you don't really have to do anything. You don't have to do a chemical reaction because you get pure copper anyways. Uh, but sometimes copper is less reactive, but it can react as well. So copper compounds are also found in mineral ores. And the example is copper carbonate. And there's another one which is copper sulfate. Copper carbonate is the one that's green color. Copper sulfate is the one that's blue in color. So I'm going to show you some of these ores. One second, let me share the screen. So copper ores. So for example, there's this ore over here. If you can see the screen, this is like copper in its original form. I mean, you can see the brownish or pure copper is like it has a pink shine to it. I mean, let me show you what pure copper looks like. So, so pure copper is kind of, I mean, although it's golden or golden brown or something, but they call it pink. Okay, so this is what pure copper looks like. Now, now the thing is that you might stumble onto rocks which are just pure copper. So you don't have to do anything. The only thing you need to do now is purify it, get rid of all the impurities that are over here. Okay, so there are some impurities that are in the rock, but it's just pure copper. So you just have to purify it. And sometimes what happens is that the copper ores are in the form of a compound. So if you look at other copper ores, the green ones are normally, the blue ones are normally copper sulfate. The greenish ones, that's copper carbonate. So they can react, they can form compounds as well. Uh, but at the moment, we are actually trying to purify this copper, which is already in its original form. So if I go back, time kya hua hai? Ek second. So we're almost out of time. So, like, remember, copper is like something that's very important. Ek second, let me see, share the screen. So at the moment, we are talking about this one. Copper is sometimes found in the original state. Okay, just like gold. And we're going to try and purify it. So this copper, which is found in its original state, is purified using electrolysis. Okay, we're going to use electrolysis to purify it. And again, I'm just going to write the rules for this. Number one, the impure copper ore is made the anode. Pure copper is at the cathode. And number three is that the solution must be made out of copper ions. And it should have copper ions. It should not have any other metal ions. So there are three rules. We're going to discuss those three rules in the next class then, okay? But remember, जो important चीज़ है ना वो ये कि copper is found in two forms. One is the original state, but it's going to be impure. It's going to have other stuff in it, like sand and rock mixed with it. And the other state is that it might be in the form of compounds. So we're not talking about compounds, we're talking about the ore which is in its original state. ठीक है? तो चलो ठीक है, let's continue tomorrow then, ठीक है?
Allah
कोई
Hafiz.
questions? चलो see you. Okay, take care. Allah Hafiz.